You're going to check to see if there's a greatest common factor. If there's a common thread through all 4 terms, you're going to take that out. Okay? Okay. Factoring out the greatest common factor. When you're trying to find the greatest common factor, it's the largest number that can be divided into all the terms. All the terms, that's where you get the word common from. It has to be common. And it has to be a factor. Okay? It's the largest number that can be divided in all the terms. That's the number for the greatest common factor. For the variable, first of all, you have to figure out what variables are common to all the terms. So all the terms have to have an x, all the terms have to have a y, or all the terms have to have an a. They all have to have one for it to be common, for it to be included in the greatest common factor. If there is a variable that's common to all the terms, it's going to be the smallest exponent. So if you have an x squared, and an x to the third, then x is going to be in your greatest common factor. If you have an x squared, x to the third, and x to the fifth, then x squared is going to be your greatest common factor. Okay? All right, so let's look at this example right here. First of all, I can easily see that my greatest common factor is what? 8. Okay? So my greatest common factor is 8. So I identify that. And then, so if my greatest common factor is 8, that means that's going to go outside the parentheses. Now, whatever I put inside these parentheses, if I distribute that 8, I have to get this back. So 8 times what will give me that term? 1 plus 8 times what will give me 8x? X. So whenever I factor something, it has to be an equivalent expression. It has to be, I have to be able to redistribute that and get back what I started. Okay, so you can always check yourself. Okay, if I redistribute this 8, I'm going to get 8 plus 8x. Okay? Factoring is like undistributing. Okay? All right, so this one over here where it says try. What's my, for my numbers, what's my greatest common factor? 7. 7 is the largest number that I can divide into 21 and 7. Okay, you want the largest number, because if you don't, now this one, it's only 7, but say if we had 4 and 8. 2 can go into both of those, but it's not the biggest one. So if you only take out a 2, you're still going to have another 2 you can take out. So you want the largest one to save yourself some work. So 7 is my greatest common factor, and b is not common to both terms, so it is not included. So 7 goes outside the parentheses, and then you have to figure out, what do I have to multiply 7 by to get this back? 7 times what is 21? Plus 7 times what is 7b to the 7th? b to the 7th. That's it. What you have left in parentheses should not have a greatest common factor. There should be nothing common to those terms in parentheses if it is as simplified as you can get it. But if there were, say you didn't take out the biggest thing, okay, and that's not the case, can't be the case with this one, but we'll look at the next one. If they were, and say you didn't factor out a factor that was big enough, you just do it again. In fact, take something else out again. And whatever you take out the second time will be multiplied to what's outside the parentheses. Okay? So let's look at this one. Let's look at the numbers first. What's the largest number that can go into 18 and 6? 6. Okay? Now, I have a choice. I can take out 6 or I can take out a negative 6. One is not more correct than the other. It's not. Okay? So it's up to you. And when we do our grouping method in a minute, you're going to have to determine that. And there will be some other things that will lead you in one direction over the other. But we'll take out a negative 6 just because we haven't taken out anything negative yet. Oh, I'm not done. Whoops, sorry. Negative 6. Then you look at your variables. Do they both have an m? Yes, so m is going to be in it. And what's my smallest exponent? M to the first power. Okay, so it's just m to the first power. Okay, If this was, say, m squared, it would still be m to the first power. It's your smallest one for your variable. So, negative 6m is going to go outside the parentheses. Now you say negative 6m times what will give me negative 18? So it will give me negative 6 times what will give me negative 18? 3. And then I already have the m, so I'm just missing the n to the third. Right? And if I multiply this back again, it's going to give me that. Okay? And then negative 6 times what will give me positive 6? Negative 1, right? And then I already have the m, so I don't need it. Okay? So that's the most direct way to get to your answer. So let me show you what would have happened if you wouldn't have taken out 6. Let's say we would have taken out a 2. A negative 2m. This is what will happen. Negative 2 times what gives me negative 18? 9, and then I need an n to the third, right? And then negative 2 times what gives me 6m? Negative 3. But what's left in parentheses, I still have a greatest common factor, right? What's my greatest common factor in parentheses? 3. So I already have this, so now I'm going to take out a 3. So if you don't take out the biggest thing, you can keep going, all right? So 3 times what gives me 9n to the third? 3 n to the third. And then minus 1, right? So what I have out here, I can multiply the negative 2 times 3. It gives me negative 6m times 3 n to the third minus 1. So I will still end up with the same answer. It just took me an extra step to get there because I didn't factor out the biggest thing. You understand? This is the same thing as that. It is just more work. Okay? So you want to work smarter, not harder. So you want to make sure you take out the largest number that can be divided into both numbers. Okay, so over here, for numbers, what's my greatest common factor? 10, what? B. 10b. So we have 10b. 10b times what? 2b squared. Okay? And then 10b times what? Just negative 1. Okay? Because b times b squared is b to the third. All right? Any questions? Is anyone not finished? All right. I have 3 terms here, but all I'm checking for is greatest common factor right now. So you look at all 3 terms. What's the largest numbers? I can go into 49, 28, and 70. 7. Okay? So what's my first term? 7. What's my second term? Positive or negative? Negative 4x. And then 10x squared. Okay, so we said our greatest common factor was 7. Okay, so when you multiply that back out again, you'll get back what you started, and you always want to look and see what's in parentheses and make sure that you didn't forget something. Okay, out 7, 4, and 10, there's no greatest common factor there, and they don't all have an x, so I know I'm good. But some of these numbers get big, and you're like, I'm not sure what the biggest one is. Okay, well, do what we did in the one where I showed you where you didn't factor out the biggest one. Factor out one that you know, and then it'll shrink those numbers down to where you can see better what else you can factor out. Okay? So over here, 32, 8, and 24. 8. 8 is the biggest number. Now, do they all have a U? No. Do they all have a V? No, so that's not included. So it's just 8. Now, I have the options to do positive 8 or negative 8. I'm just going to do positive 8. Okay? What's my first term? Negative 4u squared v, because when I multiply this, I get that back. Okay? I'm going to run out of room. Now, my next term. Good, plus u, and then minus 3. Perfect. And when I look here, there's nothing else that's common. Okay? Everybody good? Okay, so anytime you see a polynomial and you have to start factoring it, check your greatest common factor first. First of all, it shrinks everything down. It shrinks everything down to smaller values, makes it easier to work with. Okay? Now let's look at method number 2. Now this is when you have 4 terms. Anytime you see something with 4 terms, you're going to automatically think, I'm going to check to see if I can group them. And I'm going to give you a minute to write down these steps. Step 1, check for greatest common factor. Always, 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 and take that out first. Then you're going to group the first 2 terms and the last 2 terms together. You always want to make sure that those 2 groups are separated by a plus sign. And we'll look at some examples in a minute. You want the 2 groups to be separated by an addition sign. Then you're going to take the greatest common factor out of each of the 2 groups. And what will happen is what's left in parentheses will be exactly the same for both groups. And in the last step, what you're essentially doing is factoring out that common expression out of both of those. And so all you have to do is write, I call it the leftovers, which is the terms that are outside the parentheses that you factored out, times the common expression. And that'll make more sense when we actually do them. Let's look at this example. We have 4 terms. 1, 2, 3, 4. So I'm going to group my first 2 terms and then my second 2 terms. And you always want it to be separated by a plus sign. And that, right now, when I look at my third term, it's positive, so they will be separated by a plus sign. But if that were negative, then I would have to fix that. Okay? So I'm going to rewrite it with my parentheses around my groups. So I have 2ax minus bx, parentheses. Now this is plus. That's a positive, 2ay minus by. Okay? So I group my first 2 terms and my last 2 terms. Always make sure you have a plus in between them. Okay? The next step was to factor my greatest common factor out of each group. But don't forget, there's a plus sign in between them. Okay? So, what's my greatest common factor in my first group? X. X is the only thing that's common. So, x times what is 2ax? Okay? X times what is bx, negative bx? Minus b, right? There's a plus sign in between them. Plus. So many times students will forget to write that plus, and they'll think it's multiplication. It's not. Now, what's my greatest common factor here?
Y.
Y. Y times what?
2a.
Minus b. I have exactly the same thing. This is my common expression. In order for this to work, you have to have the exact same thing in both sets of parentheses. The signs have to be the same too. It can't be 2a minus b and 2a plus b. That doesn't work. It has to be exactly the same thing. Okay? Now my third step, I said write the leftovers times the common expression. Write the leftovers. My leftovers are x plus y. Okay? X plus y times my common expression, which is 2a minus b. What you're doing in that step is now, right here, how many terms do I have? Terms are separated by addition and subtraction. I have 2 terms now in this step right here, right? I have 1, 2 terms. My greatest common factor between those 2 terms is that common expression. Because this is a factor and this is a factor, right? This is a factor and this is a factor. So my common factor is 2a minus b. So in this next step, what I'm doing is I'm factoring out that 2a minus b, which leaves me with x plus y. Does that make sense? I'm taking this as my greatest common factor. And when I take this out, it leaves me with x plus y. Okay? So that's all you're doing. You're still factoring out the greatest common factor, but in that case, the greatest common factor is an expression. Okay? So, let's review the steps. Group the first two terms, the last two terms, make sure they're separated by an addition sign. Factor out the greatest common factor out of each group. Now you've created two terms. The last step, write your leftovers times your common expression. It's not wrong if you do 2a minus b times x plus y. There's nothing wrong with that. Factors can be, they're interchangeable. Like 3 times 4 is the same thing as 4 times 3. Okay, so there's nothing wrong if you reverse those factors. It's okay. Any questions? All right, I want you to try the next one. Try number 2. All right, so we group the first two, x squared minus ax, plus second two, bx minus ab. My greatest common factor in my first group is x, so when I take that out, I'm left with x minus a. My greatest common factor in my second group, I'm going to take out a positive b, so that leaves me with x minus a. I need the same thing there and there, so I'm left with x plus b times x minus a, or the reverse order of that is fine also. Does anybody have any questions? All right, let's look at number 3. In number 3, same thing. We're going to group the first two and group the second two, except that when we group the first two, 2ms plus 3mt, I said you need to have a plus in between your groups. So plus, this is negative 4ns minus 6nt. You always want a plus in between them. Okay? What's my greatest common factor in my first group? Just m, right? So what does it leave me with when I take out an m? 2s plus 3t. Now, I need to have positive 2s plus 3t in that second group. So what am I going to take out of my second group? A negative 2. If I took out a positive 2, that would leave me with negative 2s minus 3t. So if the terms are the same, but both signs are wrong, that means you didn't factor out the right sign to make them match. Okay? And so we're going to take out a negative 2. So now I can put minus 2, because that's what I'm taking out. And what I'm left with is, oh, and an n. Good, good. I'll check and see if you're paying attention. Minus 2n. Good. And so what I'm left with is 2s plus 3t. Okay, if what you get in parentheses doesn't match the first one, then something's wrong. Okay, so those are my common expressions. So my leftovers are m minus 2n, and then my common expression is 2s plus 3t. So you just have to be careful with your signs. Yes? Yes, you could write it as negative 2n plus m. Sure. Same thing. That's the same thing. The 2n, it stays negative. She asked this. Could you write this? That's the same thing. Yes. The terms can be reversed. What's important is if you redistributed this, you would end up back here. Okay? Any questions? All right, I have one more for y'all to try. Whoops, that's not it. Okay, the second part to this is the whole reason why we're factoring. We're factoring so that we can solve, okay? The purpose of factoring is to get you to your solutions, okay? Because if I take this problem right, well, these don't have numbers in it, but if I take one of these, if I take this original 4 terms, I can't solve for, say, just n, okay? This is factored form. This is factored form because it's a factor times a factor, right? If I'm going to figure out what the solutions are, we know that 0 times anything is 0, right? So, if this right here calculated to be 0, then that would make this whole thing a true statement, right? Because it'd be 0 times whatever that was. And 0 times anything is 0, right? So, we're trying to figure out what values of x are going to make that a true statement. So when I look right here, if x was equal to positive 3, then that would be 3 minus 3. So that would be 0 times, I don't even care, you can still plug in 3. 3 plus 4 is 7. That would be 0 times 7, which is 0, right? So the first solution is x equals 3. The first solution is x equals 3. What you do is after you factor it, you take each factor, set it equals 0, and solve. You take each factor, each expression, set it equal to 0, and solve. Because if you can figure out what's going to make that one expression equal 0, it'll make the whole thing equal 0. Okay? And so we do this. Once it's in factored form, x minus 3 equals 0. And x plus 4 equals 0. There are 2 different scenarios that's going to cause that entire left-hand side to be 0. So we add 3 to both sides. X equals 3. Subtract 4 from both sides. X equals negative 4. So if x was equal to 3, then it would make this whole thing equal 0. Or if x was equal to negative 4, then that would make this equal 0, causing the whole thing to be 0. Does that make sense? If I had 3 factors, if I had x plus 7, x minus 5, x, x minus 6, it equals 0. If I had 3 factors, that's 3 different factors, right? What's going to cause this one to be 0? Negative 7. What's going to cause this one to be 0? Positive 5. And what's going to cause this one? Positive 6. So this has 3 solutions. 3 solutions that will cause that to equal 0. Does that make sense? Okay. So that still holds true even if it was, let's say my factors are x minus 7 and 2x plus 3. Okay, well, this one's easy to see. What's this one? Positive 7. This one's not so easy to hand pick, right? Okay, you have to take this, set it equal to 0, and solve for x to figure out what is going to make this one be 0. So it would end up being negative 3 over 2, because you would have to subtract 3 from both sides and divide by 2. Okay? That also holds true. Let's do the same, x minus 7 and x squared plus 3. So we know this one. This one's easy. That one's 7. But you take this, set it equal to 0, and solve. So x squared equals negative 3, square root, so x equals I plus or minus I times the square root of 3. So once you get it in factored form, you take each factor, set it equal to 0, and solve them separately, and that'll give you all your solutions. All right? They're not always all real solutions, but they'll all be there. Okay? So over here, it's already in factored form. So let's just take each factor and set it equal to 0. Now, if there was a plus or minus in between these, then they're not factors anymore. They have to be factors, times each other. Okay? So you do x squared minus 3 equals 0, and 2x plus 7 equals 0. and solve both of those separately. So we would add 3 to both sides. So x squared equals 3, then what?
Square root.
Very good. Take the square root. When you take the square root, don't forget the plus or minus. So x equals plus or minus the square root of 3. Now, if I'm solving for x, that's the solution, right? Well, what else is it on the graph? What is that? The x-intercept. Very good. It's the points where that graph crosses the x-axis. Okay? Next here, I have to subtract 7 from both sides. So 2x equals negative 7. Then divide by 2, so x equals negative 7 halves. So your answer may look like a set of solutions. You could have square root of 3, negative square root of 3, and negative 7 halves. Those are all 3 of my solutions. So that graph is going to cross the x-axis at 3 places. 1 point something something, negative 1 point something something, and negative 3.5. Okay? Now, these two were already in factor form for you. You're usually never going to get handed that. So you'll have the polynomial that you'll have to factor, and then take each factor and set it equal to 0 and solve. Okay, let's look at an example of that. So we have to solve that. Your instructions will either be factor or solve. If there's an equal sign, they want you to solve. If there's not an equal sign, they don't want you to solve. They just want you to factor it. Okay? So 2x squared minus 8x equals 0. Every step I'm going to put equals 0, equals 0, equals 0. Okay? And so, what's my greatest common factor here? 2x. So when I take out a 2x, what's left? X minus 4. Good. And always check yourself. If I redistributed 2x squared minus 8x, I'm good. Now it's factored. Now you're going to take each factor and set it equal to 0. So we have, this could be like that if you wanted. It doesn't have to be, and you're not usually going to see it like that. But your greatest common factor that you take out, it's a factor. It's your greatest common factor. So here's my first factor, 2x equals 0. And my second one, x minus 4 equals 0. Okay? So divide by 2. 0 divided by anything is what? 0. Add 4. X equals 4. So my two solutions are 0 and 4. Crosses the x-axis at 0 and crosses it at 4. And I knew that I was going to have two answers. How did I know that? By the squared term. Your highest power of x tells you how many solutions that you'll have. How many solutions am I going to have in the second one? 3. I'm going to have 3 solutions in the second one. Check for your greatest common factor. What's my greatest common factor? Oh, before I do that, what do I need to do? Subtract 18 from both sides. If you're going to solve, you want it equal to 0. You're setting it equal to 0. So, subtract 18 from both sides. Well, I don't have another term to combine it with, right? So we'll just do out there. So this will be 0. So we have x to the third plus 2x squared minus 9x minus 18 equals 0. Now, do I have a greatest common factor for all 4 terms? No, I don't. So what do? I have 4 terms. What method? Grouping. You're going to do grouping. And your grouping will end up with binomial times binomial. You'll set each one equal to 0 and solve. Okay, So now I take each factor and set it equal to 0. So I have x squared minus 9 equals 0, and x plus 2 equals 0. So for the factor on the left, I'm going to add 9 to both sides, right? So I have x squared equals 9. Okay? Now I have to take the square root of both sides. So I have x equals plus or minus 3. That's where your third solution comes in. If you don't remember the plus or minus, and you just put x equals 3, then you're going to miss that other x-intercept. And so here, just subtract 2, and you get x equals negative 2. So my three solutions are 3, negative 3, and negative 2. So your homework is up here. Like I said, I can put it on Edmodo also. For these four, the first set of problems, you just need to find the greatest common factor. For the second set, you're going to be factoring using grouping. And then the last set, you're going to be factoring and then solving.